Hello, my name is Mio Muhammad Haris, and for today I'll be presenting about the project objectives. So there are two objectives, which are creating an energy management system for a diesel electric hybrid ship using Arduino Uno in Tinkercad, and second, to demonstrate the practical use of C++ programming in embedded systems and control the throttle of both electric motor and diesel engine. Alright, so next, let's take a look at our flowchart. So we have three types of flowchart in this project. So the first one is the motor throttle and direction control. The second one is the engine start, stop and throttle control. And the third one is the integrated system. So basically the integrated system is the combination of the first two flowcharts. So for the I/O list is where we list all our components that we use in this project. So we categorize each characteristics in our component, which is the I/O type, range, value, and unit. So for example, the product that we use is Mars 0907 brushless permanent magnet DC motor. So the I/O type is digital output. The range is 24 until 48 VDC. The value is forward reverse, and the unit is voltage direct current VDC.
My name is Mio Nabil and I will explain about engine, ECU and motor. For the engine, we decided to pick the Yanmar-based engine hybrid propulsion. This is because our project requires us to choose a hybrid engine for the ship, and Yanmar engine fits the criteria. Next, the ECU. ECU, also known as Electrical Control Unit, is an embedded system in automotive electronics that controls one or more systems in motor vehicle. Since the engine we use is a Yanmar engine, the ECU is also a follow-up from the Yanmar engine, as we can refer here together with the schematics. As for the motor, I choose the Mars 0907 brushless DC motor. There's two reasons. The first one is because it's worth it to be bought in the long run, as it's designed for a long life and no brush maintenance are needed, as it allows us to save costs. As for the second one is all limitations for voltage and current are below the threshold. This is because the voltage control for the input ranges from 0 to 72 VDC and has an efficiency of 90% at voltages between 24 to 48 VDC. As for the peak current, it may reach 220 amperes AC for 1 minute.
Hi, my name is Haikal. Now I would like to explain about the 12-volt Arduino relay controller. Before that, we choose 12-volt Arduino relay rather than 5-volt. For the power supply compatibility, boats commonly use 12-volt electric system for their primary power supply. Using a 12-volt relay match the boat power system, making it easier to integrate without needing additional voltage converter. With a 12-volt relay, you can connect directly to the boat's existing power source, reducing the complexity of the wiring. 12-volt also is generally designed to handle a higher current loads compared to 5-volt. This is crucial for the boat. So, for the Arduino relay, it can be used to control various devices, including the throttle of a diesel engine or electric motor, by switching a 12-volt circuit. Relay are electromagnetic switch that allow a low power signal from the Arduino to control a higher power circuit, which is in our throttle 530 milliwatt. For the throttle control, the switching action can either enable the throttle control circuit, such as allowing the current to flow to a throttle actuator, or disable it, thereby controlling the engine or motor speed or power output.
And now for the motor controller. So motor controllers are devices that control the operation of electric motors. In this project, we use KLS7245N as our motor controller. The KLS controller is compatible with the type of BLDC motor that we choose, that runs with a power of 4000 watts till 5000 watts. It also has a standard throttle input that ranges 0 till 5 volts. The KLS7245N handles the electric motors used for propulsion, giving fine control over speed and torque. Moreover, we have the PWM analog output MOSFET. So the PWM, which is also known as the pulse width modulation, is a technique for getting analog results with digital means. So the function of using Arduino PWM is to control a MOSFET and to leverage Arduino's ability to generate precise digital signals to control larger electrical loads efficiently and effectively.
Hello, my name is Muhammad Hafiz Iskandar and I will be explaining on the circuit and the coding for this project. So right now we are starting. So here are the codes that I have coded. So here are the 4 buttons, 4 switches that I code for. First switch is for the on switch and second is forward. The third is for the reverse mode and the fourth is for the hybrid mode. So right now if I turn on the engine, so it will practically turn on both. So in the real application, the turning on of the engine should be another button, but I simply in the switch. So when we turn on the engine, so both motor and engine is now on. So right now we go for forward. So right now, if we go to 0 throttle, so this potentiometer will simulate the throttle input. So right now it's like 0. So when we increase the throttle input, so like the user push or pull or twist the handle. So right now we have we have an output at the motor only. So when we increase more than 25%, now we have an output from the on the engine now. So this goes on until like 70%. So the user is putting more throttle. So when there are like maximum throttle for the engine, we can increase more so that the more speed can be put. So now motor and engine is now on. So as you can see at full throttle, we can see both motor and engine are now at full capacity. So yes, these are the code that I have coded. So right now, as you can see, there are case switches and some if else statements. So here are the throttle input like for the engine motor and throttle state at 0. So I put it at low. So no input, no output. It's a safety precaution. So I also put if both of the engine and motor forward and backwards are on, so no output will generate it because it will damage the engine and the motor if that's the case. So let's see the reverse. So as you can see, it's now at negative RPM. So the reverse is working, and also it is in hybrid also, in reverse mode also. So that's all from me. So we are also running at 14 volt, but in the application we should put more voltage and amperage. So we can connect it like this. We need to use some relays and MOSFET so to do that. But I tried to do it in this project, but I don't know why Tinkercad it's like sometimes it's working, sometimes not. So yeah, that's all for me. Thank you.
Next, we move to the conclusion part, which is the project successfully illustrate an energy management system for a diesel electric hybrid ship using C++ coding and Tinkercad. The key component includes the Yamaha-based engine, Mars 0907 brushless DC motor, and KLS 7245 and controller. The Arduino Uno managed the engine to start and stop and the throttle with a 12-volt relay for a safe high power control. This hybrid system is ideal for retrofitting older vessels to meet environmental standard. Arduino and Tinkercad make it accessible for education use. So, the objectives are achieved.